Before we begin the lesson, I'm going to remind you what we learned yesterday. For example, if I have 125x plus 3 equals 5. How do I write 125 so that the bases are the same? What should I put there? A 3, because 5 cubed is 125. Okay, so the value stays the same. I just changed what it looks like. And I was able to get the same base. And I guess here would be 1. In this example, though, what are we going to do if you cannot get the common base? Okay, so these problems, you're not going to be able to manipulate it to where you get the same base. So the first step is we're going to isolate the exponential expression. This is the exponential expression. I want that part by itself. So first, I'm going to subtract 7 from both sides. I'm left with -2 times 5 to the power of p equals -70. Next, I'm going to divide by -2, divide by -2, and I get 5 to the power of p is equal to 35. Now, unlike yesterday, we cannot make the bases the same, okay? 5 to the power of nothing will give you this 35. Not that I can think of. So what I'm going to do here, we're going to change this to a logarithm. So how do I write this exponential as a log? What am I going to write, guys? Perfect. Log 5 of 35 equals p. That's exactly how you convert it to a logarithm. Now, we're going to use something that we used the other day. We're going to use the change of base formula. The change of base formula says if you have log base b of a, you can write it as this, log a over log b. So how am I going to rewrite this one using the change of base formula? Yep, log 35 over log 5. So guys, go ahead, use your yellow calculators. You can type that in. It does not matter what number you use as your base, as long as they match. Whatever you choose to put here, it does not matter. In fact, everyone chooses different bases. You'll see that when you type it into your calculator, you'll get the exact same thing. If you want to, you can just make your bases both 10, or you can make both of your bases a 7. It doesn't matter. As long as your bases match, you'll get the same answer. All right, thank you guys. Amanda, can you say that one more time? When you type this into the calculator, you got 2.0.
No, 2.21.
2.21. You rounded, I'm assuming?
Yes.
Okay, great. All right. Let's do another example. Oh, by the way, guys, you have those fancy yellow calculators. So you can actually just type this directly into your calculator and get 2.21. You don't have to do the change of base formula. Okay, but you do need to know how to do the change of base formula, but you don't necessarily need it with these fancy calculators. Okay, let's try another example. First, I need to isolate this exponential expression. So I'm going to add 3. I'm left with 216 on this side and 8 times 11 to the 7k. Next, I'm going to divide by 8 on both sides. I get 11 to the 7k equals what? 27. Thank you. Okay, so guys, it's isolated. My exponential part is isolated. Now, next step, we're going to change to a logarithm. Larabe, how do I change this to a log? Perfect. Thank you. All right, guys, you can type this directly into your calculator because you have fancy ones. However, if you didn't have a good calculator like that, you would type in log of 27 divided by log of 11. These will give you the same answers. So let me know what number you get. 1.37. It sounded like you guys rounded. Did y'all round? Oh, y'all did it? Okay. I don't want you guys to round until the very end, okay? So we got 1.37 equals 7K, and then we're going to divide by 7. So let me know what K is equal to. 0.196. 353. Okay. There we go. So you guys are going to practice how to do this. All right. If you don't like how this looks, because I need to subtract 7, and my other classes were asking, why am I subtracting 7? So this would be 11. If you don't like how this original problem looks, I can also put the -4 in the front and the +7 in the back. Now it's kind of easier to see that your very first step should be subtracting 7. Okay, so now I'm here. Now I'm going to get rid of this negative by dividing by -1. So now I get 4 to the power of x plus 1 equals -11. Now it is isolated. There's nothing else attached to it except for the exponent. So the next step is to change this to a log. How do I write this as a log? What's wrong? Exactly. You cannot have a negative inside of the log. No negatives inside the log. You cannot do that. So this is just no solution. You can't do this. So first you subtract 10 from both sides, and you get 84 on this side. 3 times 8 to the power of 3 minus 7n. Now I'm going to divide by 3. And guys, what is 84 divided by 3? 28. Thank you. All right. And so now I'm going to change it to a log. We're done with step 1. Now we're going to change it to a log. So if I change this to a log, I'll put it up here. This will be log base 8. The answer is 28. And your exponent was 3 minus 7n. So you can type this directly into your calculator, or you could type it in like this. Log of 28 divided by log 8. You'll get the same answer. What did you guys get when you typed that in? I got 1.60245. Did you get that too? Okay, great. So now I'm not going to round yet. I'm going to round at the very end. So now I'm going to subtract 3 from both sides. So if I do that, I'm going to get negative 2.60245. No, I'll get -1. What did you guys get when you subtracted 3? 39755. Thank you. And then after this step, what should I do last? Yep, divide by -7. So we should get a positive answer. N equals, and I got 0.19965. Now, if you wanted to round, say they said round to the nearest hundredths, what would you put? You'd be looking at this number for the hundredths. So yep, you just put 0.2. If they said round to the nearest 10 thousandths, then that would be 0.1997. This depends on what they tell you to round to.